This is our second video in the series on rational expressions, section 1.6. First video we looked at just, adding fractions, subtracting fractions, right, and we did like multiplying and dividing fractions, and we of course simplified the fractions or reduced them. So we'd actually want to do fractions where you have variables involved. We call these rational expressions. So our exercises that we're going to have here are to simplify. Is that what we're going to say? Simplify completely? Let me see how I word this. Okay. We'll say simplify. Okay, so here I have number 1. Looks like I have x squared plus 4x. That's going to be the top of my fraction. That's called the numerator. Then in the bottom, we have xy plus 4y. So it turns out here we're not multiplying two fractions or dividing two fractions or adding or subtracting two fractions. We just have a fraction and we want to simplify it. We want to reduce it. So basically what you want to try doing to reduce fractions, you want to find the factors. So how does the top factor, we're going to ask? How does this red top factor? Well, what we could do, we could use the GCF method of factoring, right? GCF, there's something here in common between x squared and x, right? We can take out an x. Then you write a parentheses and ask the question, okay, what's left over after you factor out a greatest common factor of f? Well, what times x would give you x squared? X, and then you have a plus, and then what times x would give you 4x? 4. Yeah, so x, and then parentheses x plus 4 is the factorization of x squared plus 4x. It should have been purple, huh? Okay, then dealing with the denominator, can we factor that as the question? The blue denominator. Notice that xy plus 4y, those two terms, have a y in common, so we can take a y out front, write a parentheses, and ask the question, okay, what's left over, in parentheses, what times y would give me xy? Well, x, and we're going to have a plus sign, and then the question is, what times y would give me 4y? Well, 4. So on top I have x times x plus 4. On bottom I have y times x plus 4. Notice that we can cancel these x plus 4s. These are common factors between the numerator and the denominator. They can basically you can say you divide them out of the top, divide them out of the bottom, or just say cancel. So you're going to be left with simply x over y for an answer here. Let's see why that wasn't purple. Okay, there it goes, purple. That's your final answer. So there we're just reducing that fraction. Okay, let's do another example. So I got x squared minus 3x minus 10. On top and on bottom I have x squared minus 25. So here there's no multiplication, division, addition, or subtraction between two fractions. This is just a single fraction. So you have a polynomial on top of the fraction, a polynomial on bottom of the fraction. So your instinct here should be to try to factor those polynomials. Factor your polynomials. So let's see, can we factor, so focusing on the top, can we factor the top? Yeah, so your section on factoring, 1.5 is really useful in this chapter, or in this section. So here we have a trinomial, a quadratic trinomial with the leading coefficient of 1, right? 1 in front of the x squared. So we're going to make two pairs of parentheses. And put our fraction bar. So on top, we're going to put what, an x times an x to get x squared. And then we're going to find two numbers that would multiply to give negative 10 and add to give negative 3, right? So multiply to give negative 10, add to give negative 3. So what two numbers do the trick? Well, plus 5 and minus 2, right? Plus 5 and minus 2. Ooh, that's not correct, is it? Minus 5 and plus 2. So I'm going to put, let's erase that. Minus 5 and plus 2. Right, negative 5 times positive 2 is negative 10, negative 5. Plus positive 2 is negative 3. Okay, on bottom, what do we have? Ooh, I wrote the problem down wrong. This should be x squared minus 25. Let's change that to 25. So I'm going to call that the blue bottom. The blue bottom. So in the blue bottom, we have what's called a difference of squares. A difference of squares. You're going to have what? X squared minus 5 squared. Right? 5 squared gives you 25. So how do we factor that? Let me do another step here. I'm just going to copy down the top once again. X minus 5, x plus 2. So for a difference of squares factorization, we have two squares that are separated by a minus sign. You're going to make two pairs of parentheses. You're going to have a plus and then a minus. And you're going to do what? X plus 5, x minus 5. So that's how x squared minus 25 factors. X plus 5, x minus 5, difference of two perfect squares. Then we can cancel x minus 5 on top with x minus 5 on bottom. Those are common factors that can be canceled. And we're left with, finally, what's left over? X plus 2 over x plus 5. And that's your answer. All right, so I'm going to scroll a bit. Now this one we're actually going to do some multiplication with. Let's say I got, this is number 3. I have a fraction of x squared minus 9. It's the top of a fraction. Now on bottom we're going to have x squared minus x minus 6. So this first fraction is going to be multiplied by a second fraction. Second fraction being 2x plus 4 on top. And on bottom, x squared plus 2x minus 15. All right, so we're going to factor again. Factor once again. So here on top, I'm going to have a difference of two squares, right? A difference of two squares. X squared is a perfect square, and 9 is a perfect square. They're separated by a minus sign. So I can think about it, this is x squared minus 3 squared. Okay, I'm just rewriting that in that perfect square form. Oh, it didn't work too well. In the bottom of the first fraction, we have a quadratic trinomial with a leading coefficient of 1. We're going to make our two pairs of parentheses. We're going to have an x times an x to get x squared. And then we got to find two numbers that multiply to give negative 6 and add to give a negative 1. Yeah, there's a negative 1 in front of that x. You might not see it, but it's understood to be there. So multiply to give negative 6, add to give negative 1. So what two numbers multiply to give negative 6 and add to give negative 1? Well, minus 3 and plus 2, right? Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Now, you see this multiplication symbol here? There we go, purple. This is essentially glue. It glues the two fractions together. So this becomes one big fraction. I'm going to put parentheses around this first dude. We'll worry about factoring that in the next step. This on top of the second fraction, we have 2x plus 4. Make that yellow. Here you can take out a common factor If you look at 2 and 4, 2 and 4 have a common factor of 2, so I'm going to pull a 2 out there. And I'm going to put a parentheses, and then I have to ask the question, what's left over? What times 2 gives me 2x? Well, x. I'm going to put a plus, and then what times 2 gives me 4? Well, 2. I got 2 parentheses x plus 2 for my factorization of the yellow. Now, let's see. I'm going to call this guy down here at the bottom of the second fraction, x squared plus 2x minus 15. I'm going to call that green. That's another quadratic trinomial with a leading coefficient of 1, so I'm going to make 2 pairs of parentheses. I'm going to put an x in the first and x in the second. X times x gives me x squared. I got to find 2 numbers that multiply to give me negative 15 and add to give me positive 2. Multiply to give me minus 15 and to give me 2. What 2 numbers do that? Well, think carefully. How about 5 and negative 3? Right? Positive 5 and minus 3. 5 times negative 3 is negative 15. 5 plus negative 3 is 2. Now, we haven't actually factored the blue part yet, x squared minus 3 squared. I'm going to factor that now, right, in the next step. That was a difference of squares. So we're going to make 2 pairs of parentheses. One's going to have a plus, one's going to have a minus. So you're going to put x plus 3 in the first parentheses and x minus 3 in the second parentheses. And then let's copy down all of our other factors. We got the yellow 2 and the yellow x plus 2. That's all multiplied together there, the blue with the yellow. And then on bottom of our fraction, we're going to have 4 factors. These are all prime factors. X minus 3, x plus 2, x plus 5, and x minus 3. And then from there, we're just going to cancel out anything in common between the top and the bottom. So for example, the x minus 3's will cancel. 1 pair on top will cancel with 1 pair on bottom. These x plus 2's will cancel. 1 pair on top with 1 pair on bottom. And it turns out there's nothing else here that actually cancels. So you can't cancel that blue x plus 3 with that green x minus 3. You're not allowed to do that. So what are we left with? So for our final answer, we're going to be left with, I'm going to take the 2 here that's left in front. I'm going to write 2 x plus 3. So on top, and then on bottom, we're going to have what's left, x plus 5, x minus 3, and we'll just leave it like that and not bother doing any foiling or distributing here. Okay, so that's multiplying 2 fractions. And then simplifying. How about we try some dividing of some fractions? Yeah, that was number 4, was it? Let me see. That was number 3, so this will be number 4. Number 4, how about we got 5 on top and on bottom, 3x minus 6. That's our first fraction. Then we're going to divide this first fraction by, that's a division symbol, the following fraction, 3 over 2x minus 4. No, 3 over 2x minus 18. Oh, I got this all wrong. Let me restart. Restart. 5 over 3x minus 6. Is that a 6? No, that's a 36. I'm writing it. Can't read my writing. 4x minus 36. And the second fraction, 3 over 2x minus 18. Okay, that's better. That's what happens when you get old. You can't read your own writing anymore. Bad eyes. All right, so anytime you see dividing 2 fractions, see this division bar right here, before you even start factoring, you're going to want to do factoring if you can But even before you start doing any factoring, you should change that division to multiplication. Come on, it's not turning. There it goes. Purple. See this division? We're going to do stay, change, flip. So we're going to stay the first fraction, 5 over 4x minus 36. We're going to change, come on, change for me. Change division to multiplication. And then we're going to flip the second fraction. The second fraction being 2x minus 18 on top, 3 on bottom. So that's the flip, or the reciprocal of the second fraction. So it's stay, change, flip. Okay, so once you change division to multiplication and flip the second fraction, we're now going to factor. Don't worry about factoring. 5 at the bottom. How about the bottom here? 4x minus 36. You can take out a greatest common factor of 4 there, right? 4 and 36 are divisible by 4, so I'm going to take out a 4, write a parentheses, and ask the question, what times 4 would give me 4x? Well, x. I'm going to put a minus, and then what times 4 gives me 36? 9. So 4, parentheses, x minus 9 is the greatest common factor factorization of 4x minus 36. Now, that multiplication right there, that purple multiplication, that's just going to glue the first fraction to the second fraction. Now I'm going to put a little multiplication sign after this 5. Now I'm going to focus on the top here of the second fraction, 2x minus 18. Is there anything in common there between 2x and 18? Well, you can factor a 2 out, right? They're both divisible by 2, so I'm going to factor out a 2. Write a pair of parentheses and ask the question, what times 2 gives me 2x? Well, x, then a minus sign. Then what times 2 gives me 18? Well, 9. So I get 2 parentheses x minus 9, close parentheses. This is the same thing as 2x minus 18. And let's not forget that on bottom we're going to have a 3, so I'm going to have multiplication by that blue 3. Now, can we cancel anything? Yes, right? X minus 9 on top is going to cancel with the factor of x minus 9 on bottom. And now we're ready just to multiply straight across on top. We have what's left, 5 times 2. 5 times 2 is what, 10? And then we just multiply straight across what's left on bottom now. 4 times 3 is 12. I guess the big question is, are we completely done here? Are we completely done? Well, you could leave your answer as 10 over 12, but you might miss a point because this can actually be reduced, this fraction, right? We can divide out something. They're both divisible by 2. 10 and 12 are divisible by 2. So I'm going to divide out 2 out of the top and bottom. That's getting rid of a common factor of 2, so that reduces to 5 over 6, right? 10 divided by 2 is 5, 12 divided by 2 is 6. So 5, 6. All right, let's move on to one more. Dividing. Let's do another division of 2 fractions. That was number 4. Let's do number 5. How about we have x squared minus 3x minus 4. On top and on bottom of our first fraction, we're going to have y squared minus y minus 56. All right, and we're going to write a divisibility bar, or dividing bar. And then we're going to have what? X squared minus 16. And then y squared plus 2y minus 80 on bottom. So we're dividing 2 fractions again. So before you even start factoring, you want to change this division here to multiplication and flip the second fraction over. So I'm going to just write the first fraction down without factoring it. We're going to factor in the next step. I'm copying down my first fraction. I'm going to change that division there to multiplication. It's not changing. There it goes. Now I'm going to flip my second fraction over. Y squared plus 2y minus 80 goes on top. And on bottom is going to go the x squared minus 16. All right, so we want to factor the blue dude now, that we've turned that into multiplication. That is a trinomial, quadratic trinomial with a leading coefficient of 1. We can make 2 pairs of parentheses. X times x in each parenthesis to get x squared, and we got to find two numbers that multiply to give you negative 4 and add to give you negative 3, right? Multiply. Let me write this somewhere to the side for scratch, so keep that in your mind. Multiply to give negative 4, add to give negative 3. Can you think of two numbers that multiply to give you negative 4 and add to give you negative 3? I can think of minus 4 plus 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. All right, so we're going to go underneath now to the y squared minus y minus 56. That's another quadratic trinomial that we can factor in that same way. Make two pairs of parentheses. We're going to put a y in the first parentheses, y in the second parentheses. Then we got to find two numbers that multiply to give you negative 56. And then add to give you negative 1. Right, the number in front of the y is a negative 1. It's not visible, but we can write it in. When you see negative y, that means negative 1. So what two numbers multiply to give you negative 56 and add to give you negative 1? Well, minus 8 and plus 7. So we just write those in. After the y is minus 8 and plus 7. Now that multiplication there, that purple multiplication, that's just going to glue the two fractions together. I want to go on to the yellow, factoring the yellow top of the second fraction. So that's another quadratic trinomial. We can make two pairs of parentheses. Two pairs of parentheses. We're going to have a y in the first, a y in the second. Then we're going to find two numbers that what? Multiply to give negative 80. It's not working. There it goes. Multiplies to give negative 80 and adds to give 2. What two numbers multiply to give negative 80 and add to positive 2? Good question, right? How about 10 and negative 8? Positive 10 and negative 8. 10 times negative 8 is negative 80. 10 plus negative 8 is positive 2. And then we see that in the bottom, this red here, that's what? X squared minus 16. That's a difference of two squares. That's the same thing as x squared minus 4 squared, right? So we'll actually factor that in the next step. I'm going to go down here, scroll down, scroll down, scroll down. I'm scrolling down here. So I'm copying down my blue factors, x minus 4, x plus 1. I got my yellow factors, y plus 10, y minus 8. You have a big fraction bar. That's just one giant fraction bar. That purple there was kind of a bridge between the two fractions. Then in the bottom we have what? Y minus 8, y plus 7. So far I'm just copying what I had above. Now we're going to factor that red situation, x squared minus 4 squared. So that's a difference of squares. So the way you factor it, you make two pairs of parentheses. One's going to have a plus, one's going to have a minus. You're going to put x plus 4 and 1 and x minus 4 in the other. All right, so everything's factored. Now we just need to cancel anything out between the top and the bottom that are in common. How about the x minus 4's here? What else? How about the y minus 8's here? I think that does it. That's everything that cancels as far as I can see. So we're left with, for a final answer, x plus 1, in parentheses, y plus 10, in parentheses, and then a fraction bar, and then y plus 7, in parentheses in the bottom, and then x plus 4 in parentheses in the bottom. There you have it. There is the reduced version of that division on the two fractions. Yeah, so in the next video we're going to look at adding and subtracting rational expressions.